So without further ado, yes, that's a recording. So without further ado, here is Tobias, one of the founding members of BitQuad, to talk to you about the Bolt and the BigQuad deck.
Thank you, Rick. So I'm going to share my screen here. I hope you see it.
Yes.
Yeah, so welcome to this workshop about the Bolt and the BigQuad deck, basically how to build a bigger drone. So I'm Tobias. I'm one of the hardware engineers. Yes, I will enable my video. Now we can see me as well. Yes, so I'm one of the hardware engineers here, and I've been kind of heavily involved in these two, the Bolt and the BigQuad deck. So if there's any problems, you know who to blame. So today we're going to talk a little bit about an introduction to the two decks. I'm going to talk about the design and limitations. We're going to show you some example setups, and we're going to have a live demo about configuration and tuning. And we're going to talk a little bit about future work and some question and answers afterwards. So the BigQuad deck and the Crazyflie Bolt, they're intended to build a bigger drone, basically. The deck is a breakout board, and the Bolt is fully compatible flight controller. So yeah, the BigQuad deck, it basically breaks out the expansion port pins to ECs. You can have radio receiver inputs, GPS. You can have I2C expansions, and you can measure voltage and current, and you can connect a buzzer. And this is basically just by breaking out the expansion port pins that is on the Crazyflie. So it's quite a cheap way to build a bigger drone. And you have this standard M3 mounting holes that are placed 30.5 millimeter in a square, which is very common on many frames. So you can take an off-the-shelf frame and build this. The BigQuad deck, this is kind of an example we have how to build it. So you connect the ECs to these motor controller outputs, but the power needs to go often directly to the battery or to a power distribution board. And the BigQuad deck will then power the Crazyflie itself through the 5 volt that you get from either one of the ESCs or from the power distribution board. And I mean, it is a kind of cheap way to build a bigger drone from a Crazyflie, but it's a bit clumsy, like you can see here on the right. We have then the Bolt kit. I mean, this is then everything integrated into one board instead to make it a bit smaller and easier to work with. And also now it doesn't hog any of the deck expansion port pins, which can be a problem with the BigQuad deck. You can basically use all the compatible decks. It's most often a problem of mechanics, how to fit them on the BigQuad. We have the connectors to attach the motor controllers. This is so it's easy to remove it and repair if things break. There's this power distribution that is built into the board to make the design smaller, but it has a limitation of roughly 8 amperes per motor. The motor controllers, the external ones, which you connect to the connector, can actually be switched off because we have a MOSFET there. So we can go into deep sleep mode, which is sometimes good if you doing swarms or want to turn it off in another way than just disconnecting the battery. The voltage input is from 1 cell to 4 cell battery, like 3 to 17 volts. We also have this standard M3 mounting holes that are placed in the 30.5 millimeter square fashion, which is quite standard. And then we removed the chip antenna in favor of an external antenna, so you can place it in a better place for increased range. And also we have the IMU connected in a SPI manner, which then reduce latency. I don't think this was a good choice afterwards now because it just complicates the firmware, but in case of really fast drones, this could actually make a difference in the flight performance. Yes, so we come to the design and limitations. So yeah, basically the bolt is just a Crazyflie 2.1 where we kind of removed the arms and replaced what we don't need there with what we need. So here by the motor connectors, there's a MOSFET, so you can switch on and off the ESCs, this so we can go in deep sleep mode. But it also makes it possible to actually use brushed motors if you would like to use big brushed motors. We put in this XT30 connector, which is commonly used on drone batteries that can handle then 30 amps. We put these JST PH connectors, so you can connect the ESCs and you would get a cable which you can solder to ESCs and then connect to the bolt. And then we put this micro FL antenna outputs. So any 2.4 gigahertz antenna with this connector is possible to use. And then we just move the LEDs in a more favorable manner, and also the same with the power button, which is now on the side. And we replace the DC-DC converter or the LiPo 1-cell charger with the DC-DC converter. And then we have this 4 holes in the M3 squared pattern. There are some limitations with the bolt. So since the ESCs and the connectors are in like the power path, it limits the output current to roughly 8 amperes. So if you would like to build something bigger, you would have to have them on a separate power distribution board or solder directly to the battery, which means then you cannot turn them off and you will lose this functionality. You still would like, I think, to hook up the voltage, the battery voltage to the board, so you can measure the voltage. Also, the DC-DC converter that was small enough, and we could use here. It can only output 500 milliamps, and then the system consumes around 100 milliamps of these. So not a lot over for decks. For example, the lead ring can actually I think consume 400 or 500. So it can, yeah, you have to be a bit smart about that. Then also we found some issues if it's run from a one-cell battery, and that is that this DC-DC converter, it goes into some bypass mode if the voltage is low enough, and then suddenly this like off or sleep current goes from something like 25 microamps to 1 milliamp, which then will drain the battery quicker. So you need to unplug this if it's not used for like a couple of days time. And also we seen that if you have the battery connected and connect the USB, it will actually start charging the battery, which can actually be a small feature as well. The problem is that it will charge it to like 4.6 volts, which is then potentially damaging the battery. So keep them only connected in short periods of time, both, or don't connect them at the same time. Now I'm going to show you some example setups that we made. And the bolt was kind of designed for, I think, a drone of 500 grams maximum, maybe. That's what we had in mind. So what we want is basically a pretty small drone that can still have quite long flight time, carry some extra weight, but also that you can use the decks in some manner, and it would be best if you can use both on top and the bottom. So we kind of came up with this design, which then limits basically the size of the battery, because this is what's in the way if you want to have decks both on top of the quad and on bottom. But we found some design that it's working quite well. And we have one with a lithium-ion battery, which is a very high density, energy density, and can fly very long. And we have one with a more high power setup, 2 cells, which I'm going to talk about in detail. So the 2-cell example setup, it can hover roughly 10 minutes, and it has a 3.1 thrust ratio. So when you hover, it's roughly at 33% the thrust, which makes, you can maybe carry 100 grams without a problem on this one. It is built on a frame we designed that is on our mechanics repository. If you would like to try it out, and 3D print it, and it should hopefully work out of the box. We're using the bolt controller, of course. And then to reach from the top to the bottom, we're using pin headers that we soldered together, actually, because they need to be quite large. We try to build a efficient setup here. So it's not super easy, because most off-the-shelf components are in this size are built for like racing drones. But I think this Gemfun Hurricane 3018 is quite efficient propeller. I think we would have liked even a bit bigger, because the area of the propeller kind of increases the efficiency. But yeah, you still want it small. In this setup, we have motors that are then matched to the battery voltage, which is this flywheel robo 1202.5. That is like the width and height of the motor, and the kV is for matching it to the battery. So these are 5,500 kV motors, and we use this 2-cell Tattoo Airline 550 milliamp battery. And we have 4 of these Flash Hobby 7 amp ESCs, which matches roughly or pretty well our maximum output through the bolt. And then we used some accessories like zip ties to fasten the batteries, and we have this anti-vibration screws that are good to remove vibrations to the sensors, and we other things like nylon standoffs and nuts and screws. In the other setup, which is very similar, but in this one we have this lithium ion cell, which has higher energy density, so we can reach 17 minutes or even 20 at some test. However time, it will go down when you fly, of course, but and the thrust radius 2:1, you're losing a bit because you only have one cell. You could probably squeeze out more if you choose other motors, but this is, I think, a good mix between flight time and performance. So what differed this is, it's the lithium ion cells then, which fits just between the expansion connectors, and then also we would have to solder wires to the cell, because I've seen there are some battery holders out there, but you also need to consume quite a few amps from these, so I'm not sure how well these will work. Otherwise, it's the same setup. The motors are then 11,500 kV, the same motors, but a different kV to match the battery voltage, which is much lower now. So you're going to have to pull more amps to get the same power output. And then there's some bolt pointers. These ESCs that we found, they are a bit brittle, especially with the stick wires we have for the connectors. So it's very good to actually put something. We used hot glue so they don't bend, because they will break otherwise. And then soldering pin headers together, as the bottom example here. This is one way to do it, and you can use either the long ones and the medium ones to get very long headers. And I mean, you could also, once soldered, you can actually pull away the plastic part and make them very long. But this is enough to reach from the bottom to the top of the battery, and you can connect, I think, 3 decks without a problem. And then also it could be good to shorten the bolt battery wire if needed. Yes, so now we come a little bit to configuration and tuning. So these products are still in early access, which we apologize a bit for, because I think the BigQuad deck has been in early access for 4 or 5 years, but we just never have gotten into the BigQuad things. But this is something we are about to change. But this early access thing means that there's a little bit more work to get things in the air. And here I've summarized like the most common compile flags you should put in the config.mk to get it into the air. And it's enable BigQuad deck for the BigQuad. And then for the BigQuad and Bolt, you want to start disarmed. This means that you need to set the system.forceArm parameter. And then default idle thrust is good, because when you're flying brushless, you don't want these to stop spinning. So then you can set the default value. And then we have the enable one-shot 125, which is a different signal protocol, which is higher update rate. I think it has 8 kilohertz update rate instead of the standard PWM, which is 400, which you get when you build it just out of the box. So now we come to tuning, which is necessary if you're building something else than the Crazyflie 2.1, basically. You're going to have different flight performances, and the controllers needs to be tuned, and you can do this by changing the parameters in p.h, and you also need to change the position controller. And then you also might need to actually calibrate the ESCs, which today requires an external ESC programming adapter, but most of them work well out of the box. And then also I'm not going to cover the other controllers that's in the firmware, because they require other tuning, which I'm not so familiar with. So yeah, let's try to do a live demo here. I'm gonna hand things to my assistant Arnaud here, and I'm gonna switch to some new screens. So yeah, Arnaud has this camera that shows the bolt in the example here, and I have the CF client, which I'm gonna connect to the bolt. So now it has this disarming enable thing, which means I need to enable arming. It's a bit of safety precaution. So in system force arm, we have this parameter, and when I turn this to 1, you're going to see the propeller spin up at this default or idle rate. And then I'm going to fly now. The settings are actually the stock settings. I would recommend to, for the rate controller, put everything in half before you fly, because most often, basically, brushless quads are more powerful, so they need to be tuned down. So we don't want any instability the first flight, because this is the most difficult and dangerous one. But we have tested this, of course, so we know it's okay. And Arnaud has a camera in between him and the drone. Yeah. Yeah, as you can see, it's very wobbly, hard to fly. I'm using a PlayStation controller to fly through the CF client. But yeah, this is not a good performing quad. So then we can actually go into the CF client and tune this live. So I'm opening the rate controller here, and I'm just gonna tune everything down a lot. So from 2.5 for the KD to 1, then 200 on the KI, which is an integral part, and the KP, which is often the most important, I'm gonna tune down to 100. And I do this for both pitch and roll. Yes, so now the new values are set, so hopefully it's going to fly much smoother. We'll take it another try. Yeah, as you can see, can probably be tuned even a bit better, but we're not going to cover that here. But now it flies pretty well. So first I'm going to disarm this one again. And now it stopped turning, so now it's no accident takeoff will happen. I'm going to disconnect this, and I'm going to switch to Visual Studio Code here, where I prepare this new settings. So in p.h, you need to write the new values that you found out during the flight. And I'm going to make this. Yeah, I should also tell you that in my config.mk file, I enable these flags, and also add this enable one shot 125 here. I also added this convenient line, which makes it easy to program the Crazyflie, because it will automatically put it in bootloader mode when you write make cload. So I'm going to make cload now when we have the new parameters. See if I can switch and show you. Yeah, it's now blinking and updating. It will take a little while, but a convenient way to get new firmware into the Crazyflie 2.1 or Bolt. Yeah, there we got the restart. So let's switch to the CF client again. And now we can check the PID rate settings. And you can see they are now, after we restart, the values we entered in pid.h. And yeah, I need to connect. No, exactly, I need to enable this one. We're a bit short on time now, I can see as well. Yeah, and there you have it. Thank you, Anno. So we did all these things here. We also have the position controller. That's a bit simpler. That's just one value to actually change, and that is you need to find the thrust level when it's hovering, and this you can either do you can do through the stabilizer.thrust parameter. So you can hover and see what it is, and this you will then enter into the thrust base variable in position controller.pid.c, and then build and flash. A little bit about future work. Our goal for this quarter, Q4, is to bring this out of early access. And this means that things should be much easier to set up and configure. We're looking into persistent parameters so that you can easily change values and save them without having to reflash and restart things. Of course, better documentation to get you up to date or get you started. And then we're also looking at this what's called BL-Heli pass-through interface, so you can actually configure the ESCs by just connecting the flight controller via USB. So it makes it much easier. And then also we want to simplify the arming method, maybe adding stuff to the CF client or as many others do, you hold the sticks on the controller in different positions to arm it and disarm it. Yes, and that's all from me. Now to questions.
Yes, thanks so much, Tobias. So if anyone has any questions, now's the time to put them in the chat. I already saw that there are a couple from Wolfgang. Wolfgang is wondering if there is a plan for a new Bolt version that has an improved DC-DC converter.
Yeah, no, not really. The problem is space as well. So when I looked at this, there were not many that can fit the space constraint and be powerful. And also that can be very consume little power when they're off. So, which I think was a kind of important feature. But yeah, so you would have to use an external DC-DC if you need more power, which then of course makes the drone clumsier with more parts. But yeah, it's a good good thing we should look into. Maybe there's better things now.
All right. Another question from Wolfgang. He wonders whether or not we will be selling the 3D printed frames.
I mean, in the future, we hope to provide a kit so anyone can get going quickly that doesn't want to build their own. And this is of course it's on our wanted list, but then yeah, there's many priorities, and maybe then it would be a carbon fiber frame or something else. But yeah, we want to provide a kit eventually. So for those that want to get going easily and don't have to want to tune controllers and stuff, because we would have done this before. And so yeah, it's something we want to do, but when, I don't know.
And another question is, how do we charge the lithium-ion battery with soldered wires?
Yeah, so in my case, I found a charger with the big tab, so you can actually, it fits in the charging in the charger, which I think is pretty common. Otherwise, it is the same charging way as a normal lithium polymer battery. So drone chargers that can charge one cell battery can also charge these. So it's either of these ways. Even our small charger that we provide can charge the lithium ion, but you would have to build an adapter and replace the connector so it fits with the lithium ion or the XT30 connector.
All right. Something I was wondering about myself, are there any plans to sell longer pin headers rather than you having to solder them together?
Yes. Yeah, I mean, it would be nice. Maybe we should look into it, but this is maybe not the most common application. So often the minimum order quantities are among thousands of these. So if it's economically viable, I think it's a good idea. But
Right.
we have to look into it.
All right. Okay, so if there are no other questions, then let's continue. So if you would like to review this workshop, recording has been made and it will be made available